Hello guys, welcome back to my channel, Boy. It's another Simulkuy episode and we are still on the series of simulation utility. And today I would like to talk about one of the utility that is quite interesting for me because from this utility we could observe and analyze if a heat exchanger network is in the optimized state or not. And yeah, I'm talking about composite curve utility. So without further ado, let's go to the topic.
Okay, this is the simulation file that I will use to demonstrate composite curve utility. Actually, this is a sample case that you can get from UniSim design sample, but actually you can use any kind of simulation file that contains at least one is heat exchanger or LNG exchanger. Okay, so if you don't want to use this file, it's no problem. Okay, but I will use this ammonia processing sample case for this episode. And first, I will take a look at the basis environment. So for the component, I will have methane, H2O, CO, CO2, H2, N2, O2, ammonia, and also argon. Then for the fluid package, I use standard Pang-Robinson. Okay, then this is the simulation environment. It's in steady state mode. Okay, so let's continue with the utility. I will add composite curve utility. Okay, so this is the first page when we add composite curve utility. There are three kinds of exchangers that we can put into the analysis, which are heat exchangers, LNG exchangers, and also heater or cooler. But in order this utility to be run, we need to have at least one heat exchanger or LNG exchanger. So you cannot use a file that contains only heater or coolers. Okay. So for example, if I choose E101 only, okay, then you will get a message here requires an LNG or heat exchanger attachment. Okay. So I will remove this E101 by pressing the delete button, or you can right click then delete. Or you can view the heat exchanger by double clicking the tag. Okay, so I will delete this and add E102 and also E104. This. So you can select multiple exchangers, multiple LNG exchangers, and also multiple heater cooler. For the first example, I will use only one exchangers, which is E102. So after we select the exchanger, then the message here become okay. Then we check the performance. The first result that is shown is the site results. Site result is the summary of the exchangers. So in this case, E102, right? The There are two sites, 2324 and also 1819. So this is the summary. What is the inlet outlet temperature and also the molar flow rate of each pass. The next result is about the pinch result. So this is the important result that we want to take a look. We could see there is a minimum approach of 10 degrees Celsius, 7.7. Then we could see the hot and also the cold pinch temperatures, and also the average temperature on pinch. Then we could also see the utility needed. Since this is a standalone exchanger, the utility needed is 0 for cold and also hot utilities. Then we could see the pH diagram in terms of table. If we want to paste it in Excel and make graph there, but we also can see directly the graph of pH in plot. Okay. So this is the pH diagram between the hot stream and also the cold stream, or you can say also the source of heat and also the sink of it. Then you can see here, this is the pinch location. Okay, so it's in the end of the pH diagram. Okay, so this pinch is actually where the delta T minimum occurs, because if we see the entire curve, you could see that the minimum delta T between the hot and cold stream occurs at the end of the TH diagram. Then you could see also in terms of grand composite curve, but actually because this is a single exchanger, you cannot see something very interesting here. Okay, so I will give it back to the composite curve. Now let's try to add another exchanger. I will add E104 here. Then now if you see the site results, we have 4 streams because we have 2 exchangers. Then we will have the new pinch result. So this new pinch result is the resultant between these 2 exchangers. So the minimum approach will be 13 at normal condition with the average temperature of 20 degrees Celsius. Okay, you could see also in terms of table and plots. Now the plot is changed. So you could see that the pinch is shifted from the end of temperature enthalpy diagram to the middle here because the smallest delta temperature is occurred here at the middle. Now another interesting features that you can use is you can set your desired minimum approach target or utility target. For example, I want to have the system running at 10 degrees Celsius minimum approach. So I can type here minimum approach target of 10. Then you could see that it is calculated that the minimum approach is 10, but I need to have an additional cold utility and hot utility of 2.7 E6 kilojoule per hour. Okay, because in order to achieve this minimum approach, I need an external duty, yeah, for heating and also cooling. And if you see the plots, it will be shifted. You will see the end of this TH curve. Now it is not in the same vertical anymore. You see the red line is a bit to the right. So for the right side, you could see that the red line is ahead or brighter than the blue line. So this is the region which the external utility is needed. As well at the left side, you could see that the blue line is more left to the red line. So this is also where the external utility is needed. Okay, so I think this is a very important utility if you want to evaluate a heat exchanger system. If you want to design a heat exchanger network, you want to optimize the system. So this is a very important tool, and yeah, I hope it will help you to analyze your system better in terms of heat exchange. Okay, so I think that's it for this episode. I hope it helps, and see you on the next episode. Bye bye.